So following on from the previous video, we got to this stage here where the volume of our container is given by this, and the cost for our container would be the surface area of this dome here, which would be this, and then we had to times it by 2 because it costs twice as much for the dome than it does for the cylinder. So we've got to times it by 2, and then we've got to add it to the surface area of the cylinder, which is this. So this here represents our cost. Okay, so now we need to use implicit differentiation now. So using this and this here, we can use implicit differentiation now. So bear in mind that we are now going to vary r. So we are going to slide r back and forth. We're going to vary the radius. Now, as we vary the radius, because the volume is fixed, h will automatically adjust itself to fit the volume. So as we slide r back and forth, h will adjust itself automatically. So we can say that h is a function of r. Okay, and then as we slide the radius back and forth here, the cost will change accordingly as we vary the radius. So we can say that the cost is a function of the radius. Okay, now as we slide r back and forth, the volume doesn't change; it's fixed. So v is a well we can't say v is a function of r. We can't say that. V is just v. V is fixed. So bear this in mind here. Bear that the cost changes as you vary r, and the height changes as you vary r. So meaning that height is a function of the radius, and the cost is also a function of the radius. Bear that in mind, okay? So now we are going to use implicit differentiation on this and on this. Okay, so hang on. So looking at the volume here, let's use implicit differentiation. Now v, when you differentiate it, v is fixed. It's just is a volume. It doesn't change as we vary r. So what we're doing is that we are differentiating the whole thing with respect to the radius. So this then becomes 0. When you differentiate this with respect to r, it becomes this, and then r. Remember, h is a function of r. So here and here you've got r here, and this is in effect contains r. So what you've got here is you've got to use a product rule here. Okay, so differentiate this, it will then give you this. So differentiate this, it will give you this. Well, use a product rule on this, and it will give you this. Okay, so this will take you to here, and now make dh by dr the subject. So blah blah, it will take you to here. Tidy up, it will give you this. Okay, so dh by dr is given by this. Okay, and now we've got to look at the cost. Now let's differentiate the cost now with respect to r. So remember that the cost is a function of the radius. So when you differentiate this, it becomes this. Okay, and then differentiate this with respect to r. That will then give you this, and then don't forget that this is you've got to use a product rule here. So differentiate this, it will then differentiate the whole lot. It will then give you this. Okay, now dh by dr here, we worked that out earlier. dh by dr is given by this. So now let's put this into here. Okay, so remember this, put it into dh by dr. That's this bit here. Okay, and then tidy this up. It will then give you this, and then blah blah, tidy up, and then it will give you this. So when you get to this stage here, don't forget when you get to this stage here, set this to be 0 here, because we're trying to find out where the so if you have a graph of c and r here, you're trying to find the turning point of this. You're trying to find a minimum. Well, you're trying to find out where the gradient will be 0. So set this to to 0 here. So that will then give you this. Okay, and then add this to both sides. That will then give you this, and then it will take you to here. So when you get to this stage here, don't forget you factored in the all the costs, you factored in all the constraints. So when you get to this stage here, what it's saying is that if you want to minimize the cost, not the material, if you want to minimize the cost, then you've got to make the radius half the length of the height here. Okay, so if you want to if you want to minimize the cost for the water container, make the radius half the length of the height. Okay.